There's still a lot in there.
It's not that big.
January, February.
Yeah. It's like
Okay.
Okay, guys, we're on page 32. Okay, so let's read this problem here, page 32. We're just going to work through these two pages, 32 and 33, and that will be our classwork. All right, so a certain person's blood pressure oscillates between 140 and 80. If the heart beats once every second, write a sine function that models the person's blood pressure. So we can kind of think of the fact that every time it beats, it's going to kind of start at the midline and it's going to kind of rise up to 140, but then also dip down to 80. Right. So if each time the heart beats, it's able to hit that 140 and 180, it's able to complete its full cycle within that 1 second. So that's basically your period right there. Let's see, write that off a period equals. All right, so from that information, see if you can gather your A, B, C, and D value. Remember, your D is your midline. It's kind of like the center of your graph. Your A is the distance from your midline to your max, but it's also the same distance from the midline to the minimum. Okay, so spend a minute to do that. You can use your calculators if you like. And you're just going to, there's a formula that you guys are using, right? Period equals 2 pi over B. And then it's going to look right in that form, right? A, B, C, and D.
No, I don't think so. I don't remember taking it out. I have no idea. It's not my.
I think I have A ones.
Thank you.
First time putting a mask on today.
Okay, so see if you can find that midline. That midline is going to be your D value. You know, it's going to be halfway between your max and your min. So here's something that you can also consider, that your midline is going to be your average of your max and min. So you can always add the two values together, divided by 2, and that will be your D value. Okay, so I'll give you guys another minute, and then I'll go over the answers. If you're done, go ahead and feel free to try number 2. I think all these problems, I think you guys can make progress on your own, but I just want to, be there to help you along.
Wait, so how do you find one? Yeah.
well, you know the distance for the second, so you can just add. brings it darker.
What?
You know, so you know the midline, right? You know where it starts at, so the zero's gonna be at 3.1, but just add 3 and find a fun.
Oh, yeah, that's right, sorry.
Yeah.
You've done this book.
Okay, so for number one, if we find the average between 140 and 80, it'll be 110. And we also know 110 is the same distance from 140 as it is to 80. So that distance is 30. So we have your A and our D value. We talked about how the time it takes for the heartbeat to complete its cycle is 1 second. So we can set that as our period. 1 is equal to 2 pi over B. Cross multiply, we solve for B, we get B equals 2 pi. Right. So we're kind of starting at rest. So it kind of starts at the midline. It kind of matches the sine function nicely. There's no need to do any phase shift. And our sine function is increasing from the midline, so there's no need to include any sort of a reflection. So 30 is our A value, our B value is 2 pi, C is 0, and D is 110. Okay. Any questions with one?
No.
Okay, number 2. A rodeo performer spins a lasso in a circle perpendicular to the ground. The height of the knot from the ground is modeled by our equation. What is where t is time measured in seconds? And it says, what's the highest point reached by the knot? What's the lowest point reached by the knot? So if you know your A and your D value, we should be able to graph where our midline is. So we can be able to, from that midline, from the midline and the amplitude, we can figure out the highest and lowest points just based off of the A and D value, right? Okay, try that.
Have you graded it?
Yes, always radians.
Have you graded this test yet?
I have not. No. I think it may be the weekend for me to finish that.
I feel like I did Broward Star Wars.
Okay.
Like that's surprising.
Okay. What you guys get for your highest point? Okay. Lowest point?
0.5.
0.5. Okay.
Imagine not. Imagine not.
Because I was not close, about 6 over.
That's exactly what
I've never been out.
Okay, part C. We know our B value, so we should be able to figure out the period of this model. Right. Our B value is 5 pi over 3. Formula is 2 pi over B to find our period. What'd you guys get? Yeah, for C, period of the model. 6 over 5, so. Mm-hmm. And then for D, we're just entering into our equation that's given to us. All right, T is in terms of seconds, we enter 25 in for T. Practice plugging this in because we need to be in radian mode, and so let's make sure we are able to.
Okay, then.
Okay, what you guys get for part D? 2.
For what? Oh, Oh, no.
Wait, doesn't that was
Let me.
No, that would be like.
It's 150.
What's 82? I know it's like
Yeah.
180.
So 150.
Okay, any questions with number 1?
So 125? 5 to 7 questions. Are you okay? We're getting there. We're actually working this out.
Okay, try number 2. Oh, sorry, try number 3.
Oh, no. Wait, let me do this.
So the midline,
B would be just 82 plus 6. Yeah, because we have this little, we have to think, because it doesn't.
What college
oh,
is
it's
it?
up 6 feet. Oh my gosh, I get it.
The B.
Oh, wow.
No, 82 is, that's smart. It's a smart school.
Yeah, but it's separate, the highest and lowest.
Okay,
But that's not the highest and lowest. It goes higher.
Yeah, but no, it's not 150. Yeah, is that not what we're
So
finding?
we're finding the midline, which would be this middle right here.
Wouldn't it be 41?
okay, does anybody still need to look at number 2? Okay, here's number 3.
Oh,
I see.
Yeah.
I thought that was a big.
Okay, so let me read the problem here. Part of a roller coaster track is a sinusoidal function. The highs and lows, high and low points are separated by 150 horizontally.
So wait, it's like 82, the distance from the highest and like, or is there the midline?
82 feet is the distance from the highest point on the track to the lowest point on the track.
So midline is only.
41 plus 6.
Why is it in the middle then?
So 47 then.
Yes, D is 47, A is 47.
Okay, the low point is 6 feet above ground. Write a sinusoidal function that models the distance the roller coaster track is above ground at a given horizontal distance. Okay, so midline is going to be halfway between the highest and lowest point of the track.
No, that's just the thing. I think this is good.
So if we split the difference between the highest and lowest points, we can figure out our A value, right?
That was what you need. So I think if it's signed, then you're having to.
Like, if you go into history, you're either coding or it's just on there, like.
Okay, what do we get for our D value?
This is
Okay, because that D value is going to be 41 plus 6, right? Since the lowest point of the track is 6 feet above ground. Yeah, let's talk about that. So this graph here, what does that look like to you, sine or cosine? It's not what? Okay, yeah, so let's talk, well, they're only showing a portion of it. You know, this roller coaster continues, so they're only showing us only a part of it. Okay. So if we think about what a cosine function looks like, starts at the peak, goes to the midline, down to the minimum, and then back up to the peak again, right? So how much of the full cycle are we seeing in front of us? Half. So what do you expect the period to be then for 300? Yeah. Because from the peak to the minimum, we know that that's going to be half the period, right? 150 feet. And so it's going to take another 150 feet for it to finish the cycle. Okay, so if you know your period is 300, we should be able to use that to help us find our B value, right? Okay. All right, see if you're able to make your way down to A, B, C, and D. Yeah.
was just wondering.
Guys, this is long.
Guys, so the way we find a value is the distance from the midline to the height, the max of our roller coaster.
Oh, well, I'll take it. Because like.
No, I'm sorry. 82 is the distance. So you say that 82 is the highest and lowest points are separated by 150 feet horizontally, 82 feet vertically.
Oh, okay. So you did 82 divided by 2.
Divided by 2, which is 41. So I know it's 41 above and below. And 41 plus 6 will be 47.
Oh, okay.
Oh, I know.
It's just asking, I think here, out of the 150 at the 40 mark, that's how high it's tracked, right?
6 feet would be.
I don't know, because that's, the thing is, it's not, right? Oh, no. Wait, can we just plug it in here?
I
You
thought-
get to the X value. You do, right? Yeah, okay. Because 40 to the right of the y-axis is a 40. Yeah, okay. So,
Yes.
yeah, so, what's the number?
5 over 40.
Okay, so if you want
It's more fun to think about that.
Okay, how do we find 47? So we're trying to figure out the middle height of the roller coaster. We know that there's at least, it's going to be at least 41, but the bottom of the roller coaster is 6 feet off the ground. So it's going to be 6 plus 41. So the middle of the track is going to be 47 feet above ground.
But that, what is that?
It's just try.
Oh, it would make sense.
And then our A value is the distance from the center of the roller coaster track to the height and to the minimum.
Oh, that's the minimum.
The minimum is,
I was about to say, because wouldn't,
The
like,
D
you
value.
just add 3 and 3 to the other side, making A
No, they're both
44 and
No,
making
the
B.
T value is 1.5, right?
we want to know the height of the middle of the
No,
track,
A value.
which is 47 feet above ground.
So you don't want to find the height of the entire graph, just the middle of the graph. Because of the entire graph, it would be 44.
But like, I don't know.
What's your 44?
Highest point?
Okay, wait, so you said you added 6 to 41, but you only added that to one side, you didn't add it to both.
Right.
So it's because you're not trying to find the middle of the actual.
Right, I'm trying to figure out how high the middle of the track is off the ground.
You're not trying to find the entire graph middle.
It's just me, okay? We're just like a little bit.
Because it's 6 feet off. It's probably, it would start at 37.
Days one for
So we have to do that, because it's not like.
So
And
the graph is like here, right? So you add 3 to each side, making the middle 44 and A 44.
Are you trying to add numbers that aren't there?
No, okay, so I'm thinking of it as this line to the top. So the middle from this line to the top. You're saying the middle from this line to the top.
No, then you have to do.
Right, because I only care about the peaks and valleys of my graph.
Oh, okay, so this has nothing to do with it, you just add that.
Yeah, it just happens to be 6 feet off the ground.
Okay.
That's why I need that 47. Yeah. If it were not 6 feet off the ground, it would be 41.
I get it, I'm just trying to get it.
Is it just?
Yeah. That just means it's a sine or cosine.
Is it okay if I wrote it in sun? No.
There's no D value, right?
No.
There's no D value, it's just N.
If you put it in sine, you have to shift it. This is already nicely laid out for cosine.
Oh, wait, I thought it was C or N.
When I said it was 3.8,
I'm sorry?
You're just like not having a quiz.
you have 5.1.
Okay, any question about part B here? Okay, let's look at number 4.
Wait, what are you?
And then when you're in like weighted class, like this is unweighted. You get plus 7.
Okay, guys, let me get your attention, please. Okay, let me go over number 4 here. So we have buoy that is bobbing up and down in the water as waves passes it. So imagine we have, if the water was not moving, it'll just be at sea level. But then as the wave passes it, we expect that the water level is going to kind of rise and fall, right? Either above or below that sea level. Okay.
We're skipping B.
Oh, so B was,
Oh, did I just not see?
yeah, we're just plugging 40 into the equation, and then we're getting 74.434.
Okay.
Okay, so okay, from the highest to lowest points and back to the highest point, that's a full cycle. So we know that's our period there, 10 seconds. Okay, distance between the highest and lowest point is 3 feet. So I think from here we can identify our A value, right? What's our A value? Yeah. But for part B, they're going to kind of give you some hints as to whether to use sine or cosine, because at x equals 0, it says we want the graph to be at its highest point. Okay. Which graph starts at the highest point, sine or cosine? Cosine does, right? Okay. So from our period information, we can plug in for 10 in for period and solve for B. Okay, so 10b equals 2 pi. We solve for b, we get pi over 5. So we should have our a, b, or our c value is going to be 0 because we're going to line up nicely with our cosine graph. Okay. So a value is 1.5, b is pi over 5, no phase shift, and then our d value is at 0. Yes. D value is 0 is because we're starting when the water is still, and then it's going to rise and fall above the water line. Yeah, sinusoidal means it can be either sine or cosine. We're just doing the next page. Yeah.
I don't want to talk about it.
Oh, this is all.
We have to do December.
Okay. Okay, any questions with number 4? Okay, now when you read number 5, it's going to feel a lot like the global warming problem that we did yesterday. So it's actually going to have a lot similarity in terms of the equation as well. So, okay, so I think for number 5, it helps to just understand, right, that if I want to find the d value, just find your max and your min temperature, find the average between those two, and then that'll be your d value. And then once you have your d value in place, you can figure out your amplitude, your a value.
So, no, you're not talking. Yeah, it's saying the Earth.
Okay, so number 5, once you identify your max and min, your minimum is 32 degrees, your max is 77. So if I just average between these two values, I can get to my d value.
Yeah.
So 77 plus 32 divided by 2 gives me a d value of 54.5. And then I can just measure or count that distance between the midline and the max. And that'll be our a value.
Yeah, 150. Yeah, it's
Why is it?
because the total thing is 66 millimeters.
It is not. Wait, unless
Okay, so number 5, we are starting at 1, and 1 also happens to be the lowest temperature. So
Yeah.
So what do you think 5 resembles? Sine or cosine?
Cosine.
Cosine. Right. So if we can think of it as starting at the minimum, and then there's a little bit of a shift, but if we can just think of this as our minimum, we can think of it as a cosine graph, right? Cosine, we can just do a reflection of the cosine graph to get a minimum.
Is A going to be negative?
That's right, A will be negative, right? Your period is 12 months. Okay, solve for B.
it's not, you don't, it's just, it's not 20.
Oops, sorry, 2 pi over B, not 12. Okay, so normally we would want a cosine graph to start here, right? So let's create a cosine graph, and then we'll figure out how or what direction we need to shift in order to make the minimum be at 1.
You get it?
It's talking about these.
Yeah.
Alright.
So I want my minimum to start with cosine. So okay, so what I have showing is the graph in red. So what I need to do in order to shift it to the graph that I really want here. Yep, -1. Okay, so two things to notice here. We have a negative because we want to start at the minimum, so that's a good fit for a reflection of the cosine graph. And we're also shifting it to the right because we want the minimum to occur not at 0, but at 1. So we want 1 to represent January. Okay. And then part C, all you're doing is you're just entering 7 for July and 12 and for December and for X and finding the average temperatures based off this model. Okay, any questions with number 5? Mm-hmm.
How
1,000.
I was mad at dimensional analysis, sorry.
Okay, are we good with number 5? Okay, here's number 6. All right, so at time t equals 0, we're going to think of the Earth's surface is in normal position, but then the shock is going to cause the surface to move in such a way where the surface moves down first from its normal position. Okay, and then it tells us that at 300 milliseconds, it's going to reach its maximum. So it's going to be distance above the normal position. Hey guys, give me a chance just to go through this. Thanks. Okay, so it says the total difference in the Earth's vertical position is 6 millimeters. Okay, for an extremely brief amount of time, the vertical position of the surface closely resembles a sinusoidal function. Okay, so we're going to just sketch our graph here. Okay, we know the max and min is going to be 3 and -3 because we know that total vibration is just going to move at a maximum distance of 6 millimeters. Okay, at t equals 0, we're going to at the normal position, but it's going to move down, right? But eventually, it's going to make its way up and back up to its maximum position and then back down, right? So this is kind of resembling a sine graph already. Now, when is this maximum going to occur? So at t equals 300, it's moved up an equal distance above its normal position. So we know that it's going to hit the maximum at 300. And if we kind of just map out the rest of the graph, it just feels natural that every one of these increments is going to be by 100, right? Which means that our period is going to be what? Yeah, 400. Okay, so I think that's the hard part, just trying to figure out, with the limited amount of information. But it does tell us that it's moving down first, and eventually, we know it's going to resemble a sine or cosine graph, so we can kind of just make our way to the end and complete a cycle and figure out what each increment is going to be. Okay, at what time will the first minimum occur? You see that being at 100? Period of this function, we see it clearly here, 400. Amplitude, that's just the A value from the midline to the max. Okay, write an equation, we can find our B value going through our period formula. Right, cross multiply. Divide by 400. Okay, so I'm going to write the equation now. D of t, or you can just call it y if you like. We have our A value, but the sign graph is moving down, so what adjustment do we have to make? Yeah, reflection. So A is going to be -3, yeah, so. No need to worry about any phase shift. There's no, our D value is 0, our C value is 0, so just A and B, that's going to be indicated here. Okay, there's our equation. Okay, if the wave were to continue, predict the vertical position of the Earth 3.25 seconds. The T value that has been defined is in terms of milliseconds, so we got to convert this to in terms of milliseconds here. So multiply by also. So we use our calculator, enter 3250 in for T. So this tells us that the vertical position is going to be 2.121 millimeters below the surface. Or below the normal position. Okay. I want to come around and just see if you guys have any questions. Tomorrow, we're going to work on the last few pages as review. So we'll work through the last 4 pages, and then we'll have a quiz on Monday. Okay.